Hi, I'm Gerard, and this is Julian. And together we are G&J Sensing Solutions, creating a cleaner, healthier future for generations to come. We've all heard that annoying beep from a gas detector. It's irritating, but life-saving. It's low cost, effective, and proven. We're bringing that same principle to a much larger scale. The oil and gas industry is literally leaking. Every year, methane emissions waste over $13 billion. This picture shows how a gas leak spreads as it is carried by the wind. This is called atmospheric transport. Methane is invisible and odorless, but our algorithm can reconstruct that invisible plume from sensor data, telling us where the gas is coming from. This issue spans the entire US. We have over 1 million active wells, 4 million inactive wells, and 2.6 million miles of pipelines, which are all prone to leak, and they are. Methane is the second largest greenhouse gas after carbon dioxide. It's responsible for about half a degree of global warming, almost the same as carbon dioxide itself. Plus, emissions from the oil and gas equal the pollution of 177 million cars on the road every year. Current solutions exist: airborne scans, imaging cameras, and handheld devices, but they are all expensive and cover only limited areas. Plus, they are not continuous nor autonomous. Fixed sensors exist, but at a cost of $1.5 to $5,000 per node, they're just not affordable at scale. Finally, 81% of all the wells are low production, which means they really need a cost-effective solution. Our answer: a low-cost wireless sensor network for methane detection, location, and quantification. It's autonomous and scalable, ideal for remote sites. With affordable field-tested components matching industry-grade performance, we combine methane and weather sensors sending data to a base station where our algorithm pinpoints leak location and size in real time.
We seek to serve small oil and gas operators. We know there are over 2,500 of these in Oklahoma alone who need affordable monitoring. Large oil and gas companies who face huge financial and reputational risk, and the EPA needing better compliance tools. Methane makes up about 80% of natural gas, so every leak lost is profit lost. Our technology helps recover this lost value. It cuts labor costs through automation, and also helps in sustainability branding in areas whereby clean energy earns premiums. So with us, these companies earn more, they spend less, and pollute less. The leak detection and repair market was estimated to be $20 billion in 2024, and we aim to target 1% of US active wells. We have two revenue models: a one-time sale of $330 per node, self-installed by the customer, and a monthly subscription of $30 per node, which we offer full customer support from our team. We're currently testing at the University of Tulsa North Campus, building credibility through conferences, partnerships, and a growing online presence. Competitors rely on costly aerial, thermal, and laser systems, not continuous and do not provide, not scalable and do not provide continuous monitoring. We stand out through academic rigor, a practical design, and true cost efficiency. Our financial projections show strong growth from $6 million to over $100 million. A lean, scalable model built for long-term success. Speaking about success, in 2024, we assembled our team, validated our tech, and filed an IP disclosure with the University of Tulsa. Then we won the first place in the Region Bank Hurricane Pitch competition. This year, we placed second in the graduate division of the Entrepreneurs Cup competition and first in the Black Oak Social Innovation Award competition. We're currently, thank you. We're currently building our test facility, and next we plan on completing our MVP and partnering with a local company to scale by 2027. We're seeking $1.5 million to receive to conduct our pilot test and field testing and manufacturing. But tonight, we're asking for $10,000 to complete our MVP. I'm Julian Otuguba, co-founder and CTO. I'm currently a PhD student in the School of Cyber Studies, and I hold a bachelor's degree in petroleum engineering.
I'm Gerardo Vera, co-founder and CEO, a mechanical automation and petroleum engineer, and a current PhD student in cyber studies.
Our advisors include leaders at Williams and the University of Tulsa. Mr. Tom McCoy, who is currently the Senior Vice President of Upstream at Williams, personally visited our facility and endorsed our technology. We're building the technology, we know the market, and we're ready to scale. Join us as we transform methane monitoring. Join us as we build in Tulsa and create a cleaner and healthier future for generations to come. Thank you.
Thank you.
I'll start us off since we've chatted before.
Yeah.
So a few questions. I actually have a ton of questions, but I'm gonna leave room. First and foremost, congratulations on your pitch.
Thank you.
Would love to hear a little more, question number one, about how much area you're able to cover with your sensors, and walk us through scale, because I find integration can be a real pain point when working with operators. So that's one question on my mind.
Okay, so the main idea about coverage is to position the sensors around the most important facilities or most probable leak sources. The number of sensors is a very important matter. That's why we're trying to enter this market, because with our affordable price, we can allow the customers to install more sensors, which will give more resolution to the algorithms and therefore more accuracy in pinpointing the leaks and its size. What was the second part of your question, sorry?
My second question relates to cost. You've mentioned that you are lower cost compared to other competitors that you were telling us about. So tell us more about how you've achieved cost reductions.
Okay, so these technologies are very expensive because mostly because of the market they're servicing or they're aimed to. What we are doing is bringing these low-cost components, like in the home detection gas sensors we have. And the first thing we did is validate this technology. So we run a number of experiments comparing these low-cost sensors to the industry sensors that are used by the industry right now, and validate their functioning. We are currently documenting those tests, and we're going to publish scientific papers about this.
Thank you.
You're welcome.
Hi, thanks for the presentation. Talk to us about how you're going to get to those expansive revenue numbers that you showed us on the screen. If I'm doing the math right in my head, one sensor and 12 months of the subscription is about $510. In year one, how do you get to $6 million in revenue?
Okay, we are expecting to service 1% of the market of active wells in the US. We're reducing this number to only the active wells because that's not the only target market we have. As we mentioned in the presentation, we can also cover pipelines and facilities like refineries. They're huge and there are a lot in our country. So it's a bigger market than we are aiming to. Plus our projections are based on this 1%, which will be around 10,000 wells. One well requires an average of 5 sensors, so it's not just one. They need 5. And depending on the geometry and other conditions, they may need more or less, but mostly more. So that's how we're getting the numbers. We have studied the capacity and the number of workers we will need, of manufacturers and everything, so we can match this number. Thank you for the question.
How does $10,000 affect your ability to produce an MVP?
Thank you. So right now we have validated the technology in labs, like using the components individually. The next step is to combine them, create a sensing node, which will be comprised of several of these sensors. We need wind speed sensors, wind direction sensors. We need these methane concentration sensors. We have to combine them with also wireless communication devices that allow them to communicate to each other and send the data to a base station. So these are not very expensive components, but we need a number of them. And we also need a facility where we are allowed to release these emissions of methane in a controlled way so we can do this testing. So the next step is to create this, which will be our MVP, and to test it empirically in a near real-world environment.
Cool.
Thank you.
Yeah, quick question, and I want to know if you've thought about this adjacent market. It's like I work in sports and sustainability, and like one of my big clients is Alterra Mountain Company, and they own a bunch of ski resorts across the world. But one of the big issues right now is climate change. So like they're having to use more and more fake snow to power their ski resorts, which is cutting their costs. Cutting the revenue, right? So they're switching from being a ski company to now they're actually mining methane in the whole town of Aspen and using methane to power the city. So I'm curious, like, have you thought about partnering with like companies that mine methane or cities that power their city with the energy, which could maybe present a larger, volume sale if you're working with entities such as this. You thought about that?
Thank you for the question and suggestion. We haven't, but we definitely will now.
Yeah, because literally the whole city of Aspen is
Yeah.
being powered by methane gas
Yeah.
because of all the old mines around the city. So that could be a market opportunity for you to look at businesses like that.
Yes, definitely. This is all about saving energy while saving the environment at the same time.
Thank you.
Thank you.
Thank you so much.